Welcome to the Cable Design Tool tutorial. In this video, we'll cover the basics and show you how to build this simple cable assembly, so you can jump right in and start working on your own projects. Before you start designing, you'll be asked how you want to measure cable lengths. Tip to tip is our standard for manufacturing, but you can choose whichever option works best for you. Now, let's add the first component. Right-clicking on empty space in the canvas opens the quick menu, where you can select different options. We'll start by adding a right-oriented connector. Clicking the Select Connector button opens the connector selector, where you can use filters or type into the search bars to quickly find the part you need. By default, products are sorted by stock quantity, from highest to lowest. Where possible, we recommend choosing items in stock to help reduce overall lead time. For connectors that support a backshell, a list of compatible options will automatically appear after selection. A backshell serves as a protective housing that provides strain relief at the cable connector junction, and we strongly recommend using one. Now we'll repeat the process to add another connector, this time a left-oriented one. Instead of using the quick menu, we can also use the control panel on the left side of the screen. Notice that the filters remain the same as before, which is helpful when selecting similar connector types. As you can see, this connector offers a wider range of compatible backshells, which can vary by cable exit size, direction, and other features. Some also have different screw lock types. We're using a male M2.5 here. That's a 2.5mm thread which fits our setup. So make sure your backshell and screw lock match the mating connector and your application. Next, we're adding two right-oriented BNC plugs. Coaxial parts are located in a separate tab from standard connectors. You'll see a few similar options, but again, when possible, pick one that's in stock. It'll speed up the manufacturing process. For the second one, we can use the duplicate function, since we're adding the same BNC plug. We also want to add an unterminated end. Since we already know its length, we can set it right away. With all main components in place, let's center our canvas. Next, we need to define paths so we can choose which wires go between the connectors. Once a path is added, drag it into the green dots on the connectors. These represent the cable exits. Pressing the Select Wire button opens the wire menu similar to the connector menu. Again, you can use filters to find the wire you need. Once selected, make sure to confirm your choice. Now let's set the length for the S1 path. If you want to add labels, select the path and then click the label icon. Then, in the object settings, type what you want printed on the heat shrink, and just click anywhere outside the box to save it. The label will be attached to the wire during manufacturing. If you want, you can also label your connectors for easier recognition. Now we'll add path between connectors C2 and C3 and set its length. Let's also add cable. In the product filter, make sure to select the Coax tab for coaxial cables. If you know the specific manufacturer's part number of a cable, you can search for it using the filter. Now we'll add the label for path S2. Since both coax connectors use the same cable and length, we can simply duplicate the path to speed things up. As you can see, the label gets copied along with it. So we'll just update the label on the second coax path, and then we're ready to move on to the unterminated end. Let's go ahead and add the final path. Since we want the S4 path to be 1 meter in total, we're setting the length to 87 centimeters. The distance from the tip of the connector to the tip of the flying leads, which are 13 centimeters long. It's worth noting that a path can include multiple wires. First, we'll add a paired 24 AWG wire. And now a 26 AWG green wire for grounding. As you can see, you can reset the filters and add as many wires as you need. Once you're done, confirm your selection. Since this path includes multiple wires, it's a good idea to add sleeving. We'll go with standard black. It's perfectly fine for indoor testing, where no extra protection is needed. We also want to group our coaxial cables into single sleeve to create a bundle. To do this, select both paths and click the Merge Cables button. You can customize the bundle by adjusting its length or changing the type of sleeving. If you ever need to separate the paths again, just click the Unmerge button. To keep the design organized, you can select and move multiple connectors at once. We'll use the Align Horizontally option to align our connectors. Let's clean up a few more things real quick, and we'll be ready to start linking connectors. Now we can start defining the signal paths between connectors. There are several ways to do this, so let's start with the first approach. To open the pinout view, use the Link Pins option. Since some connectors are hollow shells, you'll need to select the pins you want to use from the pop-up window. For the first example, we'll use AutoLink, a handy tool for simple sequential linking. You can set where linking starts by adjusting the offset for each connector. Then, either drag the bar or type in the number of connections, which in our case is 50 since connector C1 only has 50 available pins. Because this cable is screened, we need to set its termination point. In this instance, we're connecting it to the back shelf for proper grounding. Now let's link our first BNC plug. In this example, we'll do it manually by selecting pins one by one. Instead of going back to the main canvas, you can use the schematic view to switch to a different path. Or you can change cable paths directly from the drop-down menu at the top. We can also define the termination type for flying leads and add labels. So let's start by picking a label color for the wire ends. Next, we'll define the termination. For the green-yellow wire, we'll use a grounding ring. The numbers next to flying lead F5 indicate the connection order and are added automatically. Now we'll switch to the two-core paired wire, set the termination to tinned ends, and link it to pins A1 and A2. Since we want to label the individual wires, we'll enter the text into the signal name fields. It's best to fill out both sides for clarity, but in this case, only the names on the right side matter, as those will be printed on the heat shrink during manufacturing. It's good to know you can also import your pinouts using a CSV file, which is especially useful when working with a large number of signals. To learn more, you can check out our other video on the topic. Next, we'll add few notes to explain specific parts of the design. Each note gets a unique number, and once saved, it's attached to the selected object or path. Clicking on the note pointer creates a movable arrow, which helps make the note more visible. You can drag the arrow to reposition it, add more pointers, or flip them, just like connectors. In the second note, we're specifying the length of the tinned ends on our paired cable. Again, we're using a pointer to highlight it clearly. As we finish the cable, it's a good idea to open the datasheet for a final review. It includes all the used parts, labels, path destinations, and pinout tables, everything you need for a quick overall check. Once the design is submitted and approved by both Pickering and the customer, the datasheet will be signed with an electronic signature at the bottom. Now that the cable is complete, we need to save it and submit it to Pickering. A technician will review the design and reach out if any additional details are needed. Keep in mind that once the design is submitted, you won't be able to make changes unless a Pickering technician releases it back to you for updates or approval. With that, we've wrapped up the full cable design process. And now you're ready to start creating your own projects.